Lesson 10.5, base E, or natural logarithms. I'm going to go right to this part, which is stating that natural logs are basically log base E. And E is a number, and that number is an irrational number that does not repeat or terminate, roughly 2.72. It's the second most irrational number compared to pi. Okay, and it's called the natural number, and otherwise known as the natural exponential function if the growth factor is E. Now you have natural log is a logarithm with base B being the number E. So in other words, here is a big step. We don't need to write log base E. We can write ln x. ln standing for natural log. Backwards, of course, but still natural log. So on our calculators, if we calculate e to the negative, e to the 0.5, we go second function, ln 0.5 parenthesis, and we get, well, what did I write there? Sorry. 0.5, not 2. 1.6487. 1.6487. E to the negative eighth, second function, ln, negative 8 for the power, parenthesis, there you go. Now this is a scientific notation number. It's smaller than it looks. It's negative. It's e to the negative 4, so that means 4 decimal places to the left is the actual number. So 0.0003. ln of 3 is just ln 3. 1.0986. And ln 1/4, we could write it as 0.25 or just even the fraction. Negative 1.3863. Negative 1.3863. Alright, now here we have exponential notation. Let's change it to logarithmic. Again, I could write log base E of 23 equals x. But because of the notation ln, we don't actually have to write it that way. We could just write ln 23 equals x. So this part is taken care of by the ln notation. So the next one would be the same. ln of 6 equals the exponent. That's x. Logarithmic to exponential. You take the log or natural log of something, you get the exponent. So e, because that's what ln base is, or the base of ln is, 1.2528 equals x. E, because it's base because it's ln, means base e. 2.25 equals x. Now to evaluate. Now I'm going to do this first one and see if we realize something. We have ln, or e to the ln 21. Now if we change it to logarithmic notation, we would have ln x, or unknown, we don't know what that is, equals the exponent, which is ln 21. What must this be for it to be equal? 21. So what's happening actually is that e and ln, e to the ln is, or are inverses of each other, and they will cancel each other out, and you're left with the 21. So with this one, e and ln would cancel out, and you're left with 7. Next question we have, if we change it to exponential, we would say e to what power would give you x. Well, this is x. So what must this be for it to be equal? X plus 3. So again, ln e cancels out. So over here, ln e cancels out, and you're left with 5x minus 7, whatever was in the exponent position. Now let's solve an equation and see how it works. we have 3e to the negative 2x equals 6. Divide by 3, e to the negative 2x equals 2. You have two choices. I can change it from exponential to logarithmic, which would mean I would write ln of 2 equals the exponent. Divide by negative 2, and we get ln 2 over negative 2 equals x. Another way to do it, and I'll do the other way on this question, we try and get to the same point we were at before, so we divide by 2, and we're in the same position as the last question. I could do what we learned in our last lesson, and I'll just take ln of both sides. And I choose ln because it's base e here. And in doing so, we get ln e canceling. We get negative 2x equals ln 5. And we're kind of in the same place we were in the last question, just getting there differently. So very similar, but just two different approaches. It's up to you and how you want to choose to do it. And the answers will, of course, be decimal versions of that, but I'll leave it at that. Okay? But actually, you know what? I will do one, because I want you to make sure you don't make a simple mistake. If I go ln 2, I want to make sure I cap off my parenthesis before I divide. If I don't do that, then it will take the ln of a fraction. In this case, it would be negative 1. So that's very important to understand this parenthesis right here. So that would give us negative 0.3466. Negative 0.3466. Okay? All right, well, what if we have this type of equation? Well, here, it's in natural log form, in logarithmic form, so let's put it in exponential. It's ln, so we're going to go e. When you take the ln of something, you get the power, and that gives you 5x. Divided by 5, and that will be your answer. Let's try that one on our calculator. Second function ln is e to the 4th power, cap it off, divide by 5. 10.9196. 10.9196. Next one is an exponential, or excuse me, a logarithmic form, and it is an inequality. So make sure we write down our next step carefully so that we do the inequality right. The x goes here, so negative 2 greater than, and then the base e, because that's natural log, and then we have, oh, sorry about that. We have the x, which is x minus 1. This is the x. That goes first, and then it's base e. And when you take the natural log of something, you get a power. Okay, so I had that backwards there. There you go. So we add 1 to both sides. So x is greater than e to the negative 2. So let's plug that in. So second function, ln to the negative 2, parenthesis, plus 1. So 1.1353. 1.1353. Now just remember that if it's a less than, you're going to have to cap it off at the end with a 0 because x can't be negative. Okay? And that ends lesson 10.5.